Hello students, how are you all? Since this is your first class and you have all transitioned from your class 10th to 11th, so you must be having many doubts, many queries, how class will go on, what will be the syllabus and everything. So we'll look at that all one by one and slowly. So let's make this session first a bit interactive and let's discuss all your doubts and look what you want and what are your expectations and what I expect from you all. Good evening Shri. So let me give you my brief introduction first. So my name is Nishant Garg and I'll be taking your mathematics for this HOMI batch, right? Naisha, since you are worried about taking maths and about maths since you are taking PCB, so Naisha, let me tell you one thing. From 10th to 11th, there is no difference. You have studied maths in 10th also, in your 10th also, right? So you need not worry about it. All you need to do is just focus in the class, look at all the concepts clearly, and if you have any doubt, you have me with you. You can ask me your doubts anytime and in your classes, right? I'll be solving your doubts, and even if I'm not able to solve your doubts, you can look at the recorded lectures that will be provided to you. You can look at the notes that you will have, and after that also, if you have any doubt, then you can come to me and interact with me and discuss all your doubts. So you fumble in your exams. Why, Akash? Akshat, because you people fear maths. You don't understand the concepts clearly. What you need to do is just understand the concepts and then go for question practice. The more you practice question, the more variation you will see in your questions. How questions are framed in your exams, how they need to be approached. So for that you need to have question practice. Good evening, Anish. So do you have any other general doubts or anything you want to ask? Otherwise, we can start the class, or anything you want to know, because the general instruction, I think you might have all got it in your chemistry class also, right? Hello Sahili, I'm doing good. How are you? I hope you all are good, right? Yes, so even if you have PCB, then these classes will be enough for you. You can go through all the lectures, do your DPPs, do your mocks and give them with full dedication, right? You need not make any excuses in them. You want to have dedication and consistency. Maths demand consistency as well as practice. So you need not worry about taking PCB or PCM, since this is the start of your journey and you are transitioning from 10th to 11th. So you already have maths in you, right? You have studied it. Hi all. So anything else you want to know? You want to know about your exam, like IIT or NEST, anything in general, you can talk to me about that. So all the topics that you are going to learn will be all your class 11 syllabus. You might have looked at your NCRT, right? So whatever syllabuses we have, that all will be covered. And except that we have two extra topics that is important. One will covering basic mathematics and one is principle of mathematical induction. Except that all the chapters are from class 11th only, but we'll look them at exam perspective. So IISc exam is no more conducting. So IISc just take the scores of your IIT exam and they select you in these colleges. So IISc is no more taking any competitive exam on its own. IISc, sorry. So the syllabus for JEE and CUET, rather CUET is more easy than IIT and NEST or any other exam, JEE and all. And yes, all the concepts that will be covered here will be for your JEE as well and for your CUET as well. Yes, there are some topics that are not in your NCRT. That is what I said, right? this basic mathematics that we will cover, and there is some principle of mathematical induction, and moreover there are some more topics inside the chapters that NCERT does not cover, but in your IAT and NEST they are. So we'll cover all that. You need not worry about that. Leave that to me. I'll cover all your topics that you need to prepare and have with you. So you want to know about the books, so we'll come to that later on. For now, practice on NCERT, go with the lecture notes, do your DPP practice, do your PYQ practice, and even after that, wherever you see the gap in your concept clarity and all, first fill that, and after that, if you will still need any book to learn and any book to read, then I'll refer it to you. So it will not be difficult to you no matter from which CBSE syllabus you are coming or ICSE syllabus. So that will be all good with you. We'll take it from basic to advanced and we'll cover all the concepts very clearly. So if you have taken PCB and you are asking me if you can do with that with just SciAstra help, then yes, all you need to do is just focus and stay consistent. Work well. Do not make any excuses like I said. You need to do hard work. That is what most important. Yeah, you can do black book, but that is a more advanced level thing. So first cover all your topics from class, do your NCERT very well, do our books, go for mock books, right, that we have, and then go for your PYQs. After that, if you can do all the gaps and fill them, then you can go for any other books. Or if you want to know, I can refer you Shengiz as well, but before that, you just cover all these things. Yes, it is okay if you are even from Maharashtra State Board or any board. We'll cover everything from basic to advanced. So all you need to do is just focus in the class. So I have many sources, so I don't follow just any particular book, so I won't refer you that. So that's why I am giving you everything that I cover here and everything that I get best from all the different books or different channels or whatever I have, and I'm providing you everything right here. You must do our DPPs, you must do our lecture notes. That would be enough for you. We'll be providing you enough material and you will get everything from us. So you don't need to worry about books or anything. You will get to know everything step by step. So just chill and just focus on our classes. So you want to know how do we revise questions. So for that, you need to practice them. If you will think that you will just read the solution, so what happens is, let me tell you, we read questions of mathematics and what we feel is they are so lengthy, or sometimes they don't even feel like we'll be able to approach them or look at them, and just we don't even pick up our pen to just solve it. So that is where the initial problem begin, you know. What you need to do is just analyze the question first, just pick up your pen, try to solve it. If you are not able to do that, look at the solution. But after looking at the solution, don't make it like, array, this was very easy, we can do it, and just leave that question like that. After looking at the solution, practice it at least 2 to 3 times and learn what concept it is telling you. Know what is the concept behind it, and then only that will help you. Practice as much question as you can. No, so even if your Cambridge or IGCSE gives you calculator, this won't be tough for you. There is no hard calculation required, right? Why? Because if that would be have required, then NEST and IIT would have given you a calculator inbuilt in your exams, right? And even if you have a calculator fee, and if they have it, then that is good for you, right? Again, you are asking for books, and I have question about answered you about that, so you need not worry about that. Just follow us. Yes, about DPP, I'll let you know when they will start floating after the class or after chapters, so you will get to know about that. All you need to do is just focus here. So if you are asking me 11th is harder or easy, then if I tell you in comparison with 12th, you will find it harder. Why? First is you are transitioning from your 10th to 11th. So there will be a big shock. There will be changes. You will see different things, different concepts. So in comparison to 12th, 11th is harder. I would say that, right? But just focus and stay attentive in classes. So do you have any other doubts, or should we start with the topic, because I think Nitesh sir has already given you all the instructions and basic requirement that you need. So shall we start with the class? Tell me yes or no. Okay, we can start. Let's go. Yeah, let's go. Okay, then let's start with our first topic. So what topic we have is, from our class 11th, our very first topic is sets. So what are sets? So we want to know what are sets, right? So before that, in our mathematical language, we consider everything that is present in our universe, whether living or non-living. We all consider them as elements or objects. So mathematical language consider everything living or non-living to be as objects or elements, right? And so with that, we'll define the definition of sets first. So what is a set? A well-defined collection of objects. So what does it mean? A well-defined collection of objects. What do we mean by that? So collection of objects, that you all might know. We have some objects, we just collect them and we can put them in a set. But no, that is not it. All that collection has to be well defined. What do we mean by well defined? Let us understand that with an example. So suppose I ask you collection of your 5 favorite movies. So will the answer of all of you be the same? What is your 5 favorite movies? If I ask you, someone will say particular 5 movies, some will say some other movies. So that collection differ person by person. That is not same for everyone. So that is something which is not well defined. Right? Yeah, Akshay, that would be no, right? That would be different for everyone. So that is something that differs person by person. That is changing from person to person. So that is something which is not well defined. What we call well defined, that does not differ person to person. If that is true for me, that would be true for you and for everyone. That is something we call to be well defined. So what is well defined? Which does not differ person to person. So now if I ask you all the vowels in our English alphabet, everyone will say A, E, I, O, U. And if you ask that anyone sitting in other country or anywhere, any person, that will also say it to be A, E, I, O, U. No one can deny the fact that all the vowels in English alphabets are A, E, I, O, U. So that is something, that is a collection which is well defined. So that will be considered to be a set. So what is a set? A well defined collection of objects. I hope the definition of set is clear to you all. Please tell me if it is clear, then we'll look at some examples to make it more clear. Okay, then let's move on to some example. So we have some collection here and we just have to tell if they will form a set or not. So what is the first example? Collection of 5 books. So I am asking you to collect 5 books. Will it form a set? Tell me, will it form a set? Reply class, we want to be it interactive, right? No, no, no. So everyone is saying no. And that is true. It will not be a set. And why? Because I am just asking you to collect any 5 books. So that 5 books can be anything. Your NCRT, someone will say novels or anything, any 5 books. So that will differ person to person. So this collection is not a set. Now if I ask you collection of months which start with the letter J. So all the months we have to collect which are starting with letter J. Will this form a set? Yes, this will form a set. Why? Because all the months which start with letter J are fixed. And which are those? January, June and July. So this will form a set. Now why have written this in this particular manner? Because that is how we represent a set. So we write all the elements of set one by one, separated by a comma, and then we close them in curly brackets. That is how a set is represented, right? So this is how a set is generally represented. Now a set does not have a name, right? If I give you all this, it does not have any name. So in general, we denote set by capital letters and all the elements inside it with small letters. So let me write that point here itself. So sets are denoted by capital letters. So how can we represent a set? We take a capital letter, then we put equal to sign, and then we list the elements and we enclose them in a bracket. So sets are generally denoted by capital letters and all the elements are inside it are generally, let's say A, B, C, D, E, are represented by small letters. That is by convention. Now let's come to our third example, which is collection of good students in this class. So can you tell me, will this be forming a set or not? Yes, Nargis, so like you said, the order of components can matter. So that is very important thing. So you could have written June 1st or July 1st or anything in shuffle, but that will form a single set. We can't say that are two different sets. So in a set, order of element does not matter. So in sets, order does not matter. So that can be written as a second point for us. Order of elements does not matter. So there is no set that if I can write this as this is even equal to B, A, C, E or D. So we can write elements of a set in any order. Right? So this is not a set. Next example, collection of prime numbers less than 10. Will this form a set? Tell me quickly. Yes, this will form a set. Why? Because these are fixed numbers. What are prime numbers? Prime numbers are numbers which come in their table and only has 1 as their factor, right? So what are all the prime number less than 10? 2, 3, 5 and 7. So these are the only prime numbers which are less than 10, and for any person in this planet or in this universe, this will be the only prime numbers that are less than 10. Akshat, 9 is not a prime number. Yes, 2, 3, 5, 7, that's correct. 9 is not a prime number. 9 comes in table of 3. So 9 is not a prime number. So what is the next example? Collection of vowels in the English alphabet. like I gave you that example, that will form a set because those are A, E, I, O, U. So for fifth, yes, it will form a set, and for fourth also it will form a set, and this is its answer. And what is the answer for fifth? A, E, I, O and U. So this is also forming a set. So I hope with these examples the definition of set is clear for you all, and there will be no doubt in this definition and how we consider anything to be a set and anything to not be a set. So shall we move on? This much is clear. Shall we move on? Okay, great. So now we have representation of sets. So sets are a collection of well-defined objects. Now we want to represent them. We have to write them in some particular form, right? Saili, what information do you are asking me to write? Let me know what you are asking me to write and then I'll answer that. Till then I'm moving on with this. So first representation of sets is roster or tabular form. So we have two types of representation for set. One is roster or tabular form. The other one is set builder form. So we'll look at that one by one with some examples so that will be clear for you. For these notes, so these notes will be provided for you, and if you feel you need to write them, then yes, you should write them. That will help you revise them, and you will have your own notes that will help you understand them on your own. But these all notes will be provided to you. So that is your choice. If you are able to understand it well from here, these notes will be provided to you, and if these feel enough for you, then that's great for you. But if you feel you need to have your own personalized return notes, then that would be great for you. Because in class we say many things which we can't write or we don't write. So if you can take that pointers and write them, that would be better for you. And in maths that will help you more, because if you have your own notes. Right, so we'll coming to roster or tabular form. So what does roster form says? In this we write all the elements separately, separated by commas, and we enclose them with curly brackets. Like I said before, for this, the way I wrote them, this is nothing but the set builder roster or tabular form. So what we will define it to be, we list all the elements of the set. So what we do is, we list all the elements of the set in our set, and then they are separated by a comma. So we list all the elements of the set and they are separated by a comma, and we enclose them between curly brackets. So that is what a roster or tabular form is. So we list all the elements of the set explicitly one by one, and then we separate them by comma, and then we just enclose them between two curly brackets. So let's look at some example. For example, one, 2, 3, 4. So this is the roster or tabular form for a set which has 4 elements, 1, 2, 3, 4. We list all the elements separately, they are separated all by a comma, and we enclose them between curly brackets. So this is the representation of sets in roster or tabular form. So let's take one more example. Set A, and let me write it to be 1, 2, 4, 8, 16. So in the roster form, what we do is just list all the elements, separate them by comma and enclose them between curly brackets. So this is clear for you all. Let's move on to the set builder form then. Shall we move on to the next definition, set builder form? Okay, so what does set builder form says? So in this, what happens is, we just don't list all the elements separately, we represent them with a symbol. That symbol can be anything, A, B, C, X, Y, Z, whatever you prefer or whatever you can choose, right? And then we separate them by colon or a slash, right? A colon we put, or we put a straight line kind, you can say. And then what we do, we write the property of all those elements. So what it says is, just represent the elements with a symbol, separate with a colon, and then write the property which all these elements will follow. So how do we define it? We represent elements using a symbol that symbol could be anything, X, Y, Z and so on. That symbol can be anything, separated by, so we separated using colon or a slash. So we represent every element with a symbol and then we separate it by colon or this slash, or you can say a straight line small, and then we write the property of elements. So this is the definition. I know some of you might not understand it. We'll clear that with the help of some example. So let's come to some example for this. So we have to write the set 1, 2, 3, 4, 5, 6 in the set builder form. So we are told to write this in a set builder form. So first of all, what we'll do is, we'll just put curly bracket and take any symbol. I have taken it to be X, and then put a colon there. You could put a straight line as well, but for my ease, I am putting a colon. Now we have to tell the property of all these elements. So what we can see, all these are natural numbers. 1, 2, 3, 4, 5, all are natural numbers. And what property they hold? Natural numbers starting from 1 and the maximum is 6. So that is the property that I can see here. In sets, is there always a starting element and ending element? Like, can we write this till infinity? No. So in sets, there need not be any starting element or ending element. There are infinite sets which we'll learn about further. So in infinite set, there is no ending element, or even if you say, we can start the element with anything, right? So it is not necessary that you have a starting element or a ending element, and we'll define such sets in this class further. So the previous slide, I only wrote the definition of roster form and then set builder form, and now we are looking at some examples which will help you understand the set builder form. Yes, I know you won't be able to understand set builder form completely, so that's why we are doing those examples. Sir, we won't make it equal to any other symbol or alphabet. What do you mean by that, Shri? Can you please explain me? I'm not able to understand with that. Oh, if you are asking if we have to assign set to any variable, or maybe you mean by any capital letter that I mentioned, right? So yes, why do we do that? Because, you know, coding we do, right? So in that way, if you just put a set and then we have to call it again and again, then we cannot write it explicitly. So we just give it a number, a name, A, B, C capital, and if we have to use it again and again, then it is easy to have that there. It is stored in the memory easily. So in coding that helps, because in coding sets have a very big approach. I hope that was your question. Okay, you want me to explain set builder form again? So what we do in set builder form, like in roster form, we wrote all the elements in explicit form. Like I wrote 1, 2, 3, 4, and then in this set I wrote 1, 2, 4, 8, 16. So this is just the roster or tabular form. What we do in set builder form is, we don't write the elements, we represent them using some symbol, and that symbol could be anything, X, Y, Z, and then we put a colon or a straight line, and we have to write the properties of all those elements. We have to write such a property that that set will have only that element only. So for that I am giving you 3 examples or 4 examples that will help you understand it. Even if after that it is not clear to you, we will come back to it. Okay, let's do that example first, and then if you still have doubts, we'll come back to it. So we have to write this in the set builder form. So what I took, I just took a symbol X. You could have taken anything, like you can even take it to be Y, or this is equal to even if you take some symbol Z, and then just put a colon. This much is clear to you all? This much is clear? Okay, now we have to write what? Properties of these elements, right? So what property it will hold? So what we can see from this set is, it is 1, 2, 3, 4, 5, 6. There are 6 elements and they are from 1 to 6. So what I can see is, these are natural numbers starting from 1 and ending at 6, right? So what I can write is, X is a natural number less than 7. Can I write this in this format? X such that X is a natural number less than 7. Now if I ask you to write this set in this format, so what will be your answer? You have to write all those natural numbers which are less than 7. So what will be your answer? 1, 2, 3, 4, 5, 6. So that is what our given set is. Now again, we can write in some other way also. So this is something to be noted down. So roster form is unique for a set, but set builder form is not unique. We can have as many expression for a set builder form. We can write set builder form as we want, as we understand the set it to be. So again, I can write it Y symbol representing elements of this set, separated by a colon. And what I can write? Y is a natural number such that 1 is less than equal to Y is less than equal to 6. I can write it in this format also. So Y will be a natural number, and how it will be? Such that Y is less than equal to 1, which means Y can be equal to 1 or less than that, greater than that, sorry, and Y will be less than or equal to 6. So what all this set will make? This will again make 1, 2, 3, 4, 5, 6. So now this is a homework for you. You have to write this in some other format. So just write this set in a format that will be in set builder form, and that would be different from all these two. Can you do that? Yes, you can also say X is a positive integer less than 7. Yes, x and y, you can say these are variable, or in sets we just call them symbols. Symbols that are just representing all the elements of our set. Yes, you can say x is a positive integer less than 7. That is another set builder form notation for this set. So I want more answers to this, and there could be infinite. Depends on what you can think about it. Right? Let us look at this next example. What it says, write this set in the set builder form. What are the elements? 1, 2, 4, 7, 14 and 28. So we have to write this again in set builder form. So first what we have is, we just write a symbol separating it with a colon, and then we have to look what property this set follows. What it is? 1, 2, 4, 7, 14 and 28. So can you guess what property it is satisfying, or anything that comes to your mind with this? Yes, Shri, your answer is correct that you are saying. Yes, Arya, you got it correct. These are what? These are all factors of 28. What are factors of 28? All the number which are dividing 28. So 1 divides it, 2 does, 4, 7, 14 and 28. So the first property that we can look at that is x is a factor of 28. So what factors? Only positive factors, right? Because there are negative numbers as well. So x is a positive factor of 28. No, these are not multiples. Multiples of 28 means 28, then next 28 into 2, 28 into 3, 28 into 4. We call these to be factors, not multiples. How will that help if you will only write solutions while making notes? If you can look at the PDF and have your questions, and that would help you, because I think that will consume you more of time, right? You will open the PDF and then you will look at the question and you will look at the solution, which question it belongs to. That will be more hectic and consuming for you. So it's better if you are making notes, then you can write question as well. So what are these? X is a factor of 28. So not just a factor, rather I would say it is a positive factor of 28. So all the factors of 28 are listed in this set: 1, 2, 4, 7, 14 and 20. Can you think of anything else? Yes, we can write it like that also. X belongs to n and it is a factor of 28. So if you want to write it mathematically, for that you need to know some notations and some symbols, which we'll look at further, and then I'll tell you how we can write all these mathematically. Right? So we have to write the set 1, 4, 27, 256 in the set builder form. So what property can you think of this set is following? Yes, you can write positive numbers which divide 28. So can you tell me what this set property, this is satisfying? So how I'll represent it? We'll represent it x such that we have to write the property of this set elements, right? Cube of the factors of 6. Cube of factors of 6. Factors of 6. 1, 2, 3 and 6. These are not cubes of vectors of 6. Cubes of consecutive natural numbers. Set of natural number till 4 raised to themselves. Yes, I think that would be correct. Set of natural numbers till 4 raised to themselves. So, if we look at that, what is 2 to the power 2? 4. 1 to the power 1, which is 1. Then if we take 3 to the power 3, that is 27. And then 4 to the power 4. What this will be? You can calculate it easily. 4 into 4, 16. 16 into 4, 64. And then 64 into 4, 256. So 1, 2, 3, 4. So this is 256. So what are these? Natural numbers 1, 2, 3, 4 to the power themselves. Is that clear? So how can we represent it? We can represent it as x such that x is a natural number and x is less than 5 such that x is equal to n to the power n, or wait, we can say n is a natural number and n is less than 5 such that x is equal to n to the power n. So do you want me to write it in symbolic form or mathematical way? Because that would be easy, because this is just language which we are writing, because we haven't still studied or look at what are symbols in mathematics. Okay, so you want me to show in mathematical symbols? So this is how we can write it in mathematical symbols. So how we can write this as x such that x is equal to n to the power n and n is from 1 to 4. So this is how we can express this in mathematical form. X such that x is equals to n to the power n and n varies from 1 to 4. I hope this is clear for you. So if you want to know a trick that is easy for you and that will help you write any set in set builder form if you are not able to look at it. So I'll tell you a very basic and best trick that every set can be written in this format. Right? So let's write them here in the notes. Okay, that would be okay for you. So first note which we'll have is roster form is unique. So whatever we write in roster form, that is unique, right? We can only change the ordering, but roster form will give us the same set and same representation. We can just only change the orderings, but set builder form is not unique. Right? We already saw that. We can write a set in many forms in our set builder form. And the last note that you are asking a trick so that you can look here with this example. So first let me take an example. Let's say we have a set A. So this is just any set, right? And we have to write it in a set builder form. We cannot guess or we are not able to look at what pattern it is following. So the trick here, you can write any set in set builder form and this works for any set. So trick x such that, so we take x such that x is satisfying this equation. What we can write? X minus 2, x minus 9, x minus 8, x minus 10 is equal to 0. So for any set, if we want to write it in set builder form, we can say x is such that it satisfies this. So we have returned this in factorized form and we have put it equal to 0. So now there will be 4 different factors and we want to put it equal to 0. So 4 numbers if multiplied and are equal to 0, so one of them has to be 0. So if we put this equal to 0, what we will get? Value of x to be 2. Then next x minus 9 equal to 0 if we put, we get x is equals to 9. Then from here x is equals to 8 and then from here x is equal to 10. So is that trick helpful for you? Class will end in approximately half an hour. Are you bored? Okay, you want me to tell you the factorized part again. So we want a set in set builder form such that it will give us elements 2, 9, 8 and 10 only. We want only these 4 elements. Now we take a symbol and put a colon, like that will do in every set builder form. So x we have taken such that it satisfies this equation. What this equation is? X minus 2, x minus 9, x minus 8, x minus 10 is equal to 0, right? So we have, you can consider this to be a number, a number and a number equal to 0. So we have 4 numbers which we want to be equal to 0, right? So any one of them has to be 0. Because if any one of them is non-zero, then we can't get 0 as our answer. So when I put, so from here, if I put x minus 2 is equal to 0. Oh, you are getting it interesting. I hope you enjoy that in every class and you build and keep your interest alive. So is this clear for you? Why we take 4 different factors and it is equal to 0. So any one, either this or this has to be equal to 0. Right? So if x minus 2 is equal to 0, from here what will be the value of x? We get x value to be 2. Right? Ignore, do you want me to repeat it again or did you understand it? So even if one of them is 0, this whole equation will be equal to 0. So that is not true that rest of them has to be 0. Right? So if this is 0, x is equal to 2. So if I put x value 2 here, 2 minus 2 is 0, then all these terms, whether they are 0 or not, the answer will always be 0. So similarly, I can do it for x minus 9. What this implies? X is equal to 9 then x minus 8 is equal to 0. This will imply x is equal to 8 and x minus 10 is equal to 0. That will imply x is equal to 10. So how many values of x we get? 2, 9, 8 and 10. If x take any other value than these, then this whole expression, this whole term will never be equal to 0. So these are the 4 values of x that gives this expression to be 0. So is that clear? Can we move on? So this works for any set. If we have 5 element set, 6 elements, then you can write 6 factors, 5 factors and so on. Right? But if we have infinite sets, like a set having elements which we cannot count, then this trick is not useful there. So this helps you when you have 5 elements, 6 elements or even if 10 elements and you are getting difficulty in understanding what patterns it follows. If you are able to understand, it is an easy pattern, that it is better to write it in some mathematical form, right? Like this was an easy question, 1, 2, 3, 4, 5, 6. We could easily guess this is a natural number less than 7 or this format or any other format. So that depends what is clicking to your mind. If it is easy for you to understand the pattern and that would not consume your more time, then you can explicitly write it this way. And if the set is containing less elements and you are taking time to understand what pattern it follows, you can take help of this trick. Any other way to write it? So in generally, if you want to write some set which you are not able to understand any trick about it, so any other way if you are asking me to write, so if you get anything about that, if you find any general trick to write any elements which you can't see pattern, then let me know. But for now, I am going with this trick. Any other way to write which? This set or some general set you are asking about? Okay, you want me to repeat this trick part? So we have a set A which was 2, 9, 8 and 10. So these are 4 elements in this set. Now 8, 9, 10 are consecutive numbers which you can see. 2 is just any number that comes here. We are not able to understand what pattern it is following or something of this form. Like these were numbers from 1 to 6. That was easy to see. But here we can't see what it is saying. So what we can write is x is a number such that x satisfies this particular term. What it is? X minus 2, x minus 9, x minus 8 and x minus 10. And we have put this all the factor equal to 0. Now if I multiply 4 numbers, let's say a, b, c and d, and it is equal to 0. So या तो either a will be 0 or b will be 0, c will be 0 or d will be 0. If any of these 4 is not 0, then that cannot give me 0 back as an answer. This much is clear? No, this is for set builder form. We were given a roster form and we are writing the set builder form from this. Yes, you can use this trick for all questions, but just make sure that question, the set has 4 elements, 5 or 6, even if 10 elements, then you can write it this way, but that would get hectic for you to write it in this long pattern or long chain of factors. So if you can clearly see the pattern in your question and you can calculate or decide what pattern it follows in 5 to 10 seconds, then write it that pattern. Otherwise, don't waste your time and you can simply use this thing. Shall we move on? Is this trick clear? Tell me quickly. So since you are not replying, so let's move on. Okay, it's clear, clear, okay, okay. Great, great. So let's move on. So now we will look at some standard notations. So there are sets and some predefined notations for some particular kind of sets. Like we have set of natural numbers, right? You have heard about it. What it is? 1, 2, 3, and it goes on. Then integers, whole numbers, rational numbers, irrational numbers, real numbers. So there are some standard notations that we follow for these sets. So what is the first notation? We write capital N for set of natural numbers. Then we have W for set of whole numbers, then I for set of integers. Shall I write it like this way because that will take more time? Is it understood for you all? Is it okay for you all if I just put this comma and you can understand that this will mean set of set of? Okay. Then next what we have? We have Z, which is set of, yeah, Z also represents set of integers. So we can write either I or Z. That denotes set of integers. Then next we have Q, which is set of rational numbers. Then Q, and we just put a C above it, a small c, which represents what? Set of irrational numbers. You will get to know further what this C actually represents here. So this is set of irrational numbers. Then R, set of real numbers. So these are some standard sets and these are some standard symbols that we have given to these sets. No, we don't use generally I for irrational numbers. We generally use Q complement. Generally it is Z for integers, and sometimes since I starts with integers, so some prefer I with the integers. Yes, Z is for integers as well, Z or I in standard form. Is there anything else, any other set that you can think of that is left here? If you have, then let me know. Otherwise, I can think of these much as of now. So yeah, you won't understand it. This is Q and it is just a small c above it. So for now, just know this is Q and we just put a C. So this we will learn further what this C actually represent. That will be in your set only. So as we go for further classes, you will understand that. Yeah, so if you want me to tell complex numbers also, I was not mentioning it on purpose because complex number is what you will learn further. Set of complex numbers. So you are asking me for negative numbers, right? So we have set notations for that also. So when I write Z plus, this means set of positive integers. So in Z plus, we take only integers which are positive, which means 1, 2, 3, 4, or you can just simply say this is natural number n only. Then we have Q plus, similarly we have R plus, right? And for negative, so what we write? Z minus, Q minus and R minus. So this represent what? Set of positive rationals set of positive real number, and this is set of negative integers, set of negative rationals, and this is set of negative real numbers. Anything else? Yes, complex number have a set and we represent it with C. Yes, you can write I plus also for positive integers, since if we are taking I to be representing the set of integers, then you can write Z plus or I plus. So 0 is just a number, that is not a set. So if you want 0, we have set operations, and after that we can represent that also in set form. So we will know about that further. Yes, you can represent set of imaginary numbers also. You can write that in set builder form easily. We'll look at that in our complex number chapter. Yes, since you are more of you now, since you have started asking what are complex numbers. So complex number is a chapter which we will encounter further, and we will know about in detail what are complex numbers. For now, I am just giving you an idea. Think about solving the equation x square plus 1 equal to 0. Will it have any value of x that is real and that can solve this equation, right? So this is just a hint about why complex number come into picture. We just wanted to solve x square plus 1 equal to 0. Will it have any solution in real? And by solution, which what I mean is, will it have any root? Okay, so there are some more symbols. So this represents belongs to. So this is just an English term. What it says, belongs to, something that belongs to something, like this pen belongs to me, right now. So this symbol, this is just a symbol which represents belongs to, and if I put a cut on it, it means what? Does not belong to. So this is what in English or in language term it means. This symbol represents belongs to, some things that belong to someone or in something, and this means does not belong to. So we haven't studied about null set yet. I'll tell you, will 0 belong to null set or not? You can ask this question in your next class, or if we look at null sets today, then I'll answer this question in this class only. Right. Next is this. This represents for all. So this is, we just make a V and then a straight line on it. This represents in maths for all. And the last, we write E in rotated form, shifted form, and this represents there exist. It means there exists something, right? And this means for all. That is something which is true for all. If we are using this term anywhere, which means this is true for all. So for all means, let's say, for example, for all you want to know. So for all, this represents for all. So if I give you a statement, and I say Px is equal to x square is a polynomial and I just say for all x. X की power, let me write it, x to the power n is a polynomial for all x that belongs to natural number. So what is our statement? Px is x की power n. It is a polynomial for all x belongs to n. What does it mean? That whatever value, sorry, this is for all n belongs to n. So whatever natural number I take, for all means for every natural number. So is this true? For every natural number, will this be a polynomial? Others, please reply to that. So just for all means it is true for everything that we are talking about. That is just an English language term, and in mathematics we represent it by saying this symbol. So others, is that clear to you? Okay, so I am just erasing this thing from here. I hope it was clear to you. So you want to know now about there exist also, when we will use there exist, right? So for that also, let me give you an example. Let's say same example, px is equal to x square, right? So if I say does so what I have returned, px is equals to x square, and I am asking does, what does this symbol represent? There exist a x, and this symbol represent belongs to, and what we have seen, what is this? This is set of all real numbers. So I am asking does there exist a x in real number such that px will be equal to 0. Is this statement clear for you? Naisha, what did you not understand? Can you please tell me so that I can repeat it for you? So is this statement clear? We are asking px is given to be x square, and we are asking does there exist a x, which means some value of x in real number such that px must be 0, which means we want some value of x which give this value 0. So we want if there exists or not. So this is where we use does there exists. So this is where we use the symbol of there exists. So these are just symbols which we use to just cut short our language part in mathematics. We just use symbols. Okay, you want me to tell this equation's meaning. So this is saying px is defined to be x square, right? So this is a notation. Px is some quantity which is equal to x square, or right? So I am asking if there exists some x, is there any value of x? If in English terms I just explain you. So what I am asking is there any value of x which is in real number that gives this is equal to 0? Yes, Mohammed, 0 is the answer. And why? Because if I put value of x to be 0, then if we square that, 0 square is itself 0. So yes, there exists a value of x. No, this is not roasted to set builder format. This is just a doubt for a student. He was asking why and where do we use this? There exists symbol. So these are just symbols in maths which you use to ease our writing part. Is this clear? Can I clear it? I hope your doubt was clear. Yeah. So can I rub this? Okay. So where were we? We were just looking at some symbols. Now a note for you. Let's say given some set A is equal to, take any set, I am just taking 1, 2, 3. So let's say we were given any set, I have written it in roster form. You can have any set in set builder form or roster form as well. So given any set, then we say, so 1 is an element of this set. Why? Because 1 is the element of this set. So what we can write here, 1 belongs to A. So this symbol belongs to means that it must be an element of that set. So what we can say, 1 belongs to A. Similarly, what we can say, 2 belongs to A and 3 belongs to A. But 4 does not belong to A. So these are just representation. If we are given any set or anything, we want to say if it belongs to that or it does not belong to. This is how we write. 1 belongs to A, 2 belongs to A, 3 belongs to A, and 4 does not belong to A, or any number other than 1, 2, 3 does not belong to A. So let's say in general, if some x, a symbol, this is just a symbol, x is an element of set Since in example we already took a set A, so what it says, in general, if x is an element of some set, let's call that set to be B. So if x is an element of set B, we represent it as x belongs to B. So if x is some element in a particular set, then we represent it as x belongs to B. Now if some element is not in set, then what we can write? It does not belong to set. So if some y is not an element of set B, then y does not belong to B. This is how we represent if some element is in a set or if some element is not in a set. Is this clear? Is that clear? Tell me, then we can move further. Okay, Riddhi, you are saying it is not clear. So this symbol, it represents something belongs to, and this symbol represent it does not belong to, right? So if we have any set, let's say A is a set which is 1, 2, 3. So this set has 3 elements, 1, 2 and 3. So we say 1 belongs to A. 1 is an element of this set, so we say 1 belongs to A. 2 is again an element, so we say 2 belongs to A. 3 is an element, so we say 3 belongs to A. Now we cannot say 4 as an element of this set. There is no 4 here. So what we say, 4 does not belong to A. So we just put the symbol of does not belong to and belong to. So if in general X is some element of a set, then we represent it as X belongs to B, because I have taken that set to be B here. Right? And then if I say Y is not an element of some set, then we write Y does not belong to B. Is that clear now? Riddhi, is that clear to you now? Okay, great, great. So this is a homework for you. Take this as an exercise. We'll discuss this in our next class. What you have to do, you have to convert all this in roster form, and you have to convert all these 5 in set builder form. Right? So just take this as an homework, and we'll discuss these questions tomorrow. Now we will study about types of sets. There are many types of sets, right? So by their name itself, you will understand what that means, right? You don't need to memorize them, or you don't need to mug them up. Naisha, so homework will not be uploaded anywhere. You will get this PDF just after your class, so you can access to that homework from there. So someone wanted to say something. Okay, clear? Okay, you want me to start this in next class? Okay, then you want me to end the class, or you want to talk to me about anything that you want to know in general? Then we can have a quick 10 to 15 minute discussion if this much is enough for you. And yes, we can start this in our next class if you want to have any discussion with me. Are you tired of studying maths, Akshit? So someone is saying, can we do it today? Lakshay, I'll answer your question about null set when we'll study about null set, and you can see our next definition is about null set only. So your question will be answered about when I define what a null set, empty set or void set is. So Akshat, you are asking the difference between set builder and roster form. So is that not clear to you from the definition? So what do we do in roster form? We just simply write all the elements of the sets. Let's say if I have 1, 2, 3, 4, 5, 6. These are 6 elements which are in set. So I just write all these 6 elements, separate them by comma and put a bracket there. So that is what a roster form is. But what we do in set builder form, we just denote that element with some symbol, put a colon, and we just list the property of that set. We don't explicitly write the elements of the set. So yes, Saili, you are asking about the notebooks, how much notebook you should make. So what I would recommend is, if you are preparing and writing these lecture notes, so that would be first thing for you. Then second thing, make a separate notebook for all your DPPs and all your mocks. That would be very beneficial for you all. And then you can make one for your PYQ practice and a general question practice. Okay, then some of you are saying let's carry on. So I'll just define these two definitions and we'll wind it up. Okay, so just these are very simple definitions. By the name only you can guess what it will be. So just let's do this and wind it up with some examples and this. What do you want to know, Riddhi, for all subjects? Okay, let's move on. So what it is? Empty set, null set or void set. So these has three names. We call it to be empty set also, null set also or void set. All these three terms represent same definition: empty set, null set or void set. What do we mean by empty? Empty means something that has nothing, right? The word empty itself in English means there is nothing inside it. So that is what the definition of empty set is. A set which has no elements. So a set which has nothing inside it, no elements are there. That is what an empty set is. So about notes, if you want to know, you can ask your other mentors from your other subjects, but for best it would be for you to follow that for my subject, and for other subject also that would be helpful for you, I guess. Otherwise, you can ask what approach your other mentors want you to have for that. Okay, so what is empty set? A set which has no elements. It is empty. The word empty itself means there is nothing inside it. So what it will be the definition? So how we define it? A set with no elements. So a set with no elements. So something that has nothing inside it. A set which has no. So you are asking how it becomes a set. So let's say I tell you and I ask you all the months which have 32 days. Collection of all the months which have 32 days. What will be your answer? Dhanya, can you please answer me? If I ask you all the months which have 32 days. 0. We don't say to be 0, we say no, there are no such months. Right? No months, yeah, 0. Right? There are no such months, which means that collection is empty. It has nothing inside it. It is a valid collection of all the months which have 32 days. If I ask that to you or anyone in this world, that would say there is nothing in that collection. That is an empty collection. So that's why it does not violate the definition of set. There are well-defined collection. These are well-defined collection. No one can say this is something that is not well defined. No, 0 is not a null set. 0 is a number actually. So we don't say 0 is a null set. Its answer is 0. A set which has no elements or 0 elements. So there would be nothing inside it. There are 0 elements inside it. But 0 is not a null set. Yes, we will represent it. Yes, but 0 is not a null set. So it is represented as curly brackets, or this is a symbol which we call phi. So this is just a symbol phi which represent what? Empty set, null set or void set. And these are simple just brackets. We just put brackets, and since there is nothing inside this bracket, so it represents an empty set. So these are two representations of empty sets. Either we just put curly brackets or we just use the symbol phi, and that represents a empty set. So a set which has 0 as an element. Now 0 is an element of it. So 0 belongs to that set, right? This is something that is present in that set. So we won't call it to be an empty set. That will be a non-empty set. That is what definition says, right? 0 becomes its element. 0 is an element of that set, right? So that will itself violate the definition of empty set. A set with no elements, something that has no elements. Now since 0 is an element of that set, so that won't be an empty set. Nargis, is that clear to you? And Lakshay, to you too as well? Nargis and Lakshay, I hope that would be clear to you. Let's move on further. So, what is an empty set or null set? A set with the no elements. Set which has no elements. It is represented as curly bracket or with a symbol which we call to be phi. What it is? We call it phi. This is a symbol which represents phi or a empty set. So, set builder form, there is no particular definition in set builder form. Like I said, if I represent this only, the example that I gave you, for example, x such that x is a month with 32 days. So, this is a set builder form, right? We put symbol separated with column and we just wrote the property. What property it is? It is a month with 32 days. So, this is a valid set builder form. So, what will be the answer of this? This is nothing but empty set. Akshat, is that clear now for this example? Let's take some more one more example. Another example, x such that x is a natural number less than 1. So, this is another example. What it says? X is a natural number which is less than 1. So, will this set has any element? Will this set have any element? Tell me quick. Will this set has any elements inside it? X such that x is a natural number less than 1. No, right? This will have nothing. So, this also represents an empty set and we represent it by using curly brackets. It will be empty, yes. So, this is also an empty set. So, there is no particular way in which we can write an empty set in set builder form. There are many such sets which can be empty and hence this is an empty set. Now, next is singleton set. By the word single, what do you mean? Single means just one, right? So, how do we define a singleton set? A singleton set is a set which has only one single element. So, a set with only one element. Yes, you are right. So, a set with only one element. Single means one. So, a set with only one element is called a singleton set. So, how do we define it? A set with one element. So, any set which only has one element is called a singleton set. Can you tell me some example for a singleton set in the set builder form or roster form? In roster form, what will be? For example, singleton 1 or we can represent it as singleton 2, right? Can you tell me some example in roster form, set builder form? So Dhanya, you are asking why didn't we represent phi inside the curly bracket? That is a very interesting question. So if we put this phi inside this curly bracket, let's say if I write it this way, so doesn't that looks like something this? Inside a curly bracket we have put something, so that becomes an element of a set. So phi is a symbol, it is just a notation, like you have A, B, C, D, these are some letters which are in English alphabets. So phi is like that, you can consider it to be a symbol like that. So if I put it inside curly bracket, that becomes an element of a set. What I can say from here is, if I write this as A is equal to phi, and then what I can say, phi is an element of A, right? But for a set to be empty, there should be no element inside it, means phi must have not been inside A. So that's why we don't put phi inside the curly bracket. Is that clear? Is that clear, Dhanya? Let's move on. So some of you have given me answers about this singleton set, and yes, you are right. X is an even prime number. So yes, that will be a singleton set. Even prime number. What is an even prime number? Even prime number is just 2. Rest all the prime numbers are odd. Why? Because if you take any even number except other than 2, that will come in the table of 2. So that will not be a prime number. So the only even prime number is 2. So example that you have told me, for example, x such that x is a even prime number. So what this set will have? Singleton 2. Right? So this is just a singleton set. X is an even prime number which is singleton 2. Yes, X is a month with less than 30 days. That is also a singleton set. The only month that has less than 30 days is February, right? So that set will have only February as its element. So that will also be a singleton set. So you can write as many as examples that you want for a singleton set, and similarly you can write as many examples as you want for an empty set. That depends on your imagination and what you can think of. So set is an interesting topic which gives you think about what would be an empty set, what would be a singleton set, and how we just mathematically represent all the terms and symbols. So shall we end this class for now today? We'll move and look at for further definitions in our next class. Is there any doubt from this class? Anyone? Is there any doubt? Yes, you will get your homework in your notes. You can access to that homework in your notes, and I want you all to do that homework. At least try it. I want answers from you tomorrow of that homework, and even if you are not able to do some question, don't stress or don't take any tension. We will look all these questions in our class. So just try to do them all. So there exists symbol just represents something that is existing. In English, that what we mean. There exist. There exists means something that is existing. There is existence of something. You can look at this recorded video of this lecture and you can understand what there exists means further. So we will take all the doubts in our next class. Whatever doubts you have, don't worry. We'll look at about that in our next class. And for now, we are ending this session. Thank you so much. end life.